just to have a well-rounded product.
Hi everyone, I'm Gabby. I'm from the Street Savvy team. I'm going to go first because I'm having on-campus teams at this point. So basically, we were thinking about how there's a huge urban population nowadays. Over 50% of the world's population currently live in urban areas, and in years coming, that's projected to rise up to 70%. Also, tourism industry is increasing. It's becoming cheaper and faster to get to different places. In New York City alone, in the last year, 54 million tourists came to visit the city. So there's a lot of commotion. People are constantly moving and going to new places. And this also, while it creates a lot of opportunities, you can go visit places, it creates a lot of problems. Because when you're not familiar with an area, you can put yourself at risk when you're walking from point A to point B. If you're not familiar with the risks associated with the area, you won't have your street smarts about you and you don't know what to look out for. So we have some statistics. 43% of women have experienced street harassment in only the past year. 37% of Americans feel unsafe when walking, even within a mile radius of their own home. And even here in New York City, 86% of residents believe that crime is a major problem. We're all familiar with that feeling, the nervous feeling in the pit of your stomach when you're walking. You're thinking, I don't know if I should be here. I don't know if I belong here. I'm not sure how safe this is. And also sometimes it can even happen when you're completely unaware. Maybe you're oblivious. You think that the area you're in is very safe. I personally can speak to that. I moved to Santiago of Chile last year. I lived there for a year. And I used to run in this park and it seemed very safe to me. There was always a lot of people around daytime. And after a few runs, I actually witnessed the assault of two 16-year-old girls. And if I had had an app that could tell me about the risks of this park, that had instilled in me the knowledge that locals have, that gave me the street smarts, I wouldn't have put myself in risk and neither would have those girls. So now we're going to have pass over the mic to Patrick, who's going to talk a little bit about our solution.
Thanks a lot, Gabby. So enter Street Savvy. So ordinarily, regular routing algorithms will either give you the quickest or the shortest distance from point A to point B. We want to enable you to go safely place to place. So right now, we've created, so using New York City crime data from the last year, we've created and this is a tongue twister, a kernel heterogeneous mixture density estimator. I think I nailed that one. Which will essentially assign probabilities to the of an event of a crime happening at a certain location. And using this, we can compute the safer route should you so choose. So we have these two weights, the shortest distance and the risk weight. And if we were to rate risk more highly, you'll see that we'll actually get a much different route that will route you through the safer areas of the city. This will empower people to explore places that they wouldn't ordinarily feel comfortable. And we also think that this will also help people be more aware of their surroundings. We can also see the underlying data using the crime map, and you can see kind of the distribution of the crimes that we identified in Midtown Manhattan. So with that, I'd like to point out my team over there. They're wonderful people. And thank you very much for your attention, and we'd love to hear your questions.
You started the talk by mentioning statistics for, particularly for women getting harassed in the street. So I was wondering, do you, in your predictions, do anything with gender or sexuality?
Yeah, so there were a few different things we were thinking about taking into account. Unfortunately, the data we had available to us for this hackathon didn't have data based on who the victim was, and nor did it have the timestamp. But we thought that if we were to have both of those, if we could get a data set with that information, it would be even more powerful tool that you could enter user information and also time to personalize the app even more. Because the type of crime that's going to happen to you around 3 p.m. is very different from the type that could happen to you 2 a.m. Likewise, if you're a woman versus a male, depending on your age, the things you're worried about are very different. So we definitely did think about that. Unfortunately, the data was not available to us in this moment.
So the risk weight takes into account the distance and time, speed.
It takes, yeah, so.
Sure, so I can give that one. So these are heuristic based on this probability density, and it weights those different components. So the risk weight will weigh the risk more heavily, and if the short distance weight will weight the distance more heavily, you get a trade-off based on distance.
So what are your priorities, getting somewhere very fast or getting there as safely as possible? So maybe you're willing to take a more roundabout route. I think you can't really put a value on safety. So we give the users to decide.
And how did you start? What's that vision street around? You mentioned it was street around.
I think Three Players was the one, or Ray Rose was the one who looked up that.
Yeah, so that was a statistic pulled from, I think, the Gallup poll.
So if a guy whistles to the girl walking that to street around?
Yes.
So that's based in the risk.
That's not taken into consideration in our risk calculator. That was just a statistic as to the types of people who want to use the product. The risk calculator takes into account strictly crime data at this point, though we thought of a lot of other possibilities, ways to expand the product. So you could take into account open businesses. I personally, if there were a lot of open businesses on there, would want to walk down that road versus one where there are a lot of closed businesses. Not only is that a safe haven, but you know there's more people around. So we did think of a lot of other ways to reach so much potential with more data to improve the use of time.
Okay, so the risk score is based on, the risk weight is based on the crime.
Probably a drive in that area.
If you had to, so clearly this path is pretty inefficient as you're showing right now. If you had to assign a risk weight that you default Google Maps to, where would you put it and why?
That you default Google Maps to?
Yeah, meaning that it should be applied for everyone. What would be an appropriate level of avoiding risk?
Great question. So that's a very personal question. So
Well, but I'm saying you're setting it for the population.
right. It's a bold assumption, and we haven't been really able to tune it based on how comfortable people feel about, going out of their way, kind of having that trade-off. So can't give you 100% confident answers, but we do think we've seen that a small increase in the risk coefficient will give you a slightly different path, but a slightly more safe path. So there is some sort of trade-off that I'm sure would be beneficial for everyone.
I think it's also that in general users, maybe it's something like Google Safe Search, like you have an option to turn it on or off. And I think that the ability to personalize that is really important. And also it would be really interesting to integrate it with Google Maps because Google has so much data on who you are. So they could take into account much more your identity, they know the time, they know your general patterns.
But because so much hate crime is happening in parks and there's on your map there, happens to be in the square park. So imagine I work with apartment stores here in New York City, and seeing applications, and you always tell stores to report cars. How would you sell me that? It just seems like from your result, it all indicates that.
So this is another thing you're thinking about of ways to improve and extend that is a really good way to extend it would be to distinguish between types of crimes. So I would say with this park, especially a relatively small one like Maxim's Park, then there's not going to be murder or like violent assaults. If it's a lot of pickpocketing, we had actually suggested that you can have somewhat of a warning saying, like, beware there are pickpockets in this area. So I think it would actually encourage tourists to not be worried to explore new areas that are very crowded. Like, for example, someone who maybe isn't as used to coming to an urban population, maybe this is their first time in New York City, it can be overwhelming. Maybe they're intimidated by Times Square and won't stay there. But if you're informed beforehand and you know what to look out for, I think it could even encourage.
Hi guys, I have one request. We would like to limit questions to the judges because we have limited time. You will have good amount of opportunity at the networking session at 4 o'clock. You can ask teams a lot of questions, so put the hat on and answer questions. I'll pass on to the next team. That's
Hi everybody, we are Data Line. Sorry, I'm Francisco Arcea, Tony and Steve and Aaron. We'll help back there. So we are the students at Columbia. We decided to take some of the Yelp data that we had that the Data Hackathon was nice enough to publish and see what we could do with it. So it's a little more likely than the last one. The last one was really incredible. So thank you. So what we tried to define here is understand what makes a restaurant bad. And how bad are they relative to the restaurants that are close to them or within some sort of cluster? And so we did a few different analyses. one of which was a cluster analysis where we clustered by region and the restaurant type. So here what you'll see is essentially a map on longitude and latitude of our restaurants, right? And so we see clusters here. I think there are 8. Yes, 8. And this actually does take into account not only the longitude and latitude, because that would be very silly to only incorporate those that are near. I mean, if I want Mexican, we don't want to take that into account that they should be similar, right? And if we scroll a little bit farther down, what we can see are good and bad restaurants. So this is an interesting graphic, and I really like it, because these purple dots right here, these small dark purple, are good restaurants. And this heat map covering these good restaurants are bad restaurants. So what we see is a high probability density right here on the strip of Las Vegas. So what we find is that you can be a really bad restaurant and still stay alive so long as you have the right location. So that's kind of intuitively true, right? All restaurants are all about location. So if we scroll a little bit further down, if we take our cohorts from the first image and we zoom in right on the strip, we can see what the actual ranking is of a given restaurant within a cluster. So this is the strip again. And what we're saying is here are really good restaurants, and here the dark red are very bad restaurants. And so we just defined some relatively simple but elegant way to find out which restaurants are bad. So we didn't actually use Yelp's review entirely. We made a modification. We took ratings that were reviews that were scored as 1 and 2, clapped them together, and said, okay, let's see if we can look at what people say about you, the actual review text, and see how similar that is for predicting the number of user experiences. And so we end up saying is, if we move a little bit further up, what the actual word is and its importance in telling how bad of an experience you have. So if we take a look at this example up above, if we zoom up, move up a little bit here we have our first cluster, which I believe is this group right over here. So what we find is Red Rock Casino is the worst performing restaurant there. And what are we hearing about it? We're hearing disappointment, overpriced, management, and so it's a very simple model at this stage. As we get more time, we definitely do much more sophisticated analysis. But this gives us a little bit of understanding about what it needs to suck. And so if we go to another cluster, maybe for example the actual Las Vegas Strip, what do we find? We find that the worst hotel, or the worst restaurant is Hooters, which we thought was absolutely hilarious. And so if we look about some of the words and how they relate to the bad experience here, we see a lot of ridiculous, disgusting, understand, disappointed, overpriced, and that's all describing what is a bad experience. And so what we can offer here as a product is something for restaurants to actually be able to learn, not just about their own Yelp website, right? Any restaurant can go and look at their own website and learn from the comments there, but this gives you a market to say, hey, look, how am I doing relative to all of my other cohort? Then please, any questions? Yes.
How much variation did you see in the words that you gave back here? Because it looked like there was a lot of overlap and disappointing and such.
Yeah, so actually one definite thing, so there are about 2,073 words uniquely that we use within our corpus. There's definitely a lot of similarity. We collapsed them just with some simple stemming that we would definitely do if we had a little more time. Honestly, it was a little late in the evening, and I probably should have added the stemming, but I didn't get the chance to. And it was only after, so it was actually a very large matrix. It was 80,000 by 2,000. So inverting that and actually computing the lasso path was very complex. So I should have looked at it beforehand, but we did.
So I meant more across different restaurants.
Oh, across different restaurants. Yeah, so this doesn't, so you're right, there's definitely a lot of overlap across the restaurants, which is to say that people tend to describe restaurants very much in the same way. But that's definitely something we could try to attempt to modify in the future. Yeah, so the audience in this sense, we would be marketing to restaurants directly. In some way, I think that a major caveat is that Yelp has all of this data. They could do this. This is something that they, in fact, should offer. And why they don't, probably just they haven't thought of it yet. Analytically, it seems like a very tractable problem. But I think it's actually a nice problem. It's something that offers restaurants the opportunity to learn why some people might have a bad experience. Because I think, maybe I'm optimistic in thinking that restaurants don't want to be bad. And maybe along the script they don't care, but elsewhere they might think so. Yes, sir.
Did you question at all the validity of the elevator?
Yes, so we definitely pre-process some of the reviewers. So you can't give uniform treatment to all users and all reviews, right? So if you were a user that only had 5 reviews, we took all of those out. We could also do a much more elegant rating scheme. I think for a first pass, using 5 min of previous reviews is sufficient. Because one thing that you'll notice is you get a lot of tourists. Actually, a huge mass of the data is populated by only single reviewers. In fact, it took out something around 30% of the data by taking out people with only 1 review.
What was the most surprising result?
I guess I didn't really think that much about what I was going to see up until I saw it, right? And I gave uniform probability there. And when I saw Hooters, I thought that was hilarious. And so I guess I just wasn't expecting or thinking about what kind of change would come up. And I guess in some way, it matched intuition to think about, like, oh, Hooters came on a restaurant strip in Las Vegas. I guess I could see why people would rate that score. Any other questions? So I just like to say thank you to my team and everybody else and for the opportunity to speak here. Thank you.
Where's the next one?
Yeah, okay, so I think second I have another confusing thing. Yeah, I think they're going
laptop's not working. Switch them out. Your microphone doesn't work. You're up. Yeah.
No worries. All right. Okay, so you just tried it.
Let's just be like around the corner. Let's just meet like near the camera. It's a life.
You don't have to like. You should understand.
Just with the HDMI cable. It's okay for a second, right? Oh. Alright. Hey guys, we're Team Zappy Live. I'm Adrian. This is Jay. We got the fear in the back, and we're going to be showing you what Zappy is. So what we did last night was leverage big data and machine learning to generate T-shirt designs that are snapshots of the internet throughout time. So Zap will show us how to get a Zappy right now. You do a comment, press the Get Zappy button, and then select a date in the future. So this can be any time in the future. You have no idea what's going to be on your Zappy, but you know what time you want to have your Zappy generated. To give you an idea what happens is we have an algorithm that will go through Reddit and other social media networks and just cool places that are represented on the internet and identify the popular topics of that day. Then we extract keywords from the topic, such as
Ola Honey Way. And from those, we pull images from Ironbird and other photo websites and identify the most appealing pictures. And finish it off by adding a nice layer of visual finesse to make it a true piece of art, like this lovely turtle over here. Jai will tell you about how we're actually identifying the pictures and doing the awesome machine learning.
Yeah, one of the issues that we came across was that some of the pictures are not worth printing on a t-shirt. So we looked at the ImageNet deep learned model that was fine-tuned the figure style data set. We used the Cafe Berkeley Vision library to install that on a server and have an aesthetic ranking and filtering system to have images that are worth putting on a t-shirt.
Exactly. Cool, and very quickly talk about what you guys here, how we're actually adding that final layer of visualization charm.
Hey, so we try to create this cool experience, basically visualization, the internet overlay of t-shirt. So on top of pulling the information, we also create this filter that is like paint, water paint like visualization that will go with an image that it represents beautifully what people have on their mind the same day.
Yeah. Cool. So that's Api. We're excited. We're gonna keep tweaking this so we're getting better pictures and more relevant content, and hopefully we can start printing on real shirts in like the next week or so. So yeah, they're prototypes.
Have you looked into the cost of getting like a nice picture printed on a t-shirt?
That's an awesome question. So yeah, we have. There's an awesome company called Scalable Press, which will print if you just do individual purchases for $12, and they also handle the shipping. And the great thing is they have a great API, not just shirts, but also mugs, whatever, where you can define what image you want, the specifications, dimensions. It's really cool. So it should be just a clean integration. Yeah.
Could you?
Right. So just to clarify, we're at this stage we're not trying to predict what will be the trending topics. The person that thinks of future date says that they want their shirt to be generated from all the content on that date. So they're not going to actually get the shirt before the date. They'll get it like at the end of the day, ideally, when there's been like enough internet activity on the day.
So it's predicting that activity in the future, or
it more summarizes this. Yes.
Aggregates into a kind of summarization of visual representation of the day and what's trending on that picture.
They're also there just of you knowing what you're going to get in that day. So the image you're going to get on the represent that day on the future. So you need to like kind of gamify what you're going to get.
And one of the inspiration examples was the black and blue dress that went viral. So right? So you would have the black and blue dress t-shirt while it's in dress.
How would you sort of cross-validate that you knew from previous learning that thing that you predicted you the most popular thing on the internet, the most popular internet? How do you actually do testing? And then in that, what is your metric of distance? Like how far off are you working? Correct.
We haven't looked that deep into that. One of the ways we were thinking of doing that was on two ends. First, the personalization. That you give keywords that you are your own defined metrics, that you want a t-shirt that's about puppies, police officers, and whatnot. So the second metric was we were trying to use image segmentation and labeling to get a sense of what's the objects in there in the image. So that acts kind of like a distance metric between what you want, what's trending on the day.
And in terms of the way we're sourcing this demonstration, this was purely from Reddit, it's the most popular thread. So Reddit, you never doubt them, they're always the voice of the internet. Voice God. Voice God? Question? Yeah.
how much of the future?
Right, so that's a question. I think we kind of talked to some people. It seems like 1999 will be comfortable price that they'll be willing to pay for such a thing, which has a level of uncertainty. The production of the shirt is actually $12 from the sale price, so that's a nice markup, but that's still something we're definitely focused on.
One of the interesting things is that people want to buy different t-shirts, different days, or like sending gifts, basically gift order for like a secret Santa.
And the cool thing we also talked about is not making, so you can not offering previous shirts from the past. So like kind of what you guys saw would be just more of a mosaic or a collection of what we generated, but intrinsically by only allowing shirts to be sold from the future, that there will be from future pictures, that will create a value to the ones that because of limited supply. Yeah.
So have you thought about in any way trying to use some function to decompose all of those images for the day into like a single one?
Yeah, we thought about that. This is quite more.
Like you can take like a bunch of these, like average.
To match everything together. So we thought about that. It would be more complex to create a beautiful visualization.
Even if it was like
What?
even if it was like aesthetic, like
yeah. So I don't know. Depends on the investigation on the design level of the share.
What about the?
Yeah. Which, by the way, looks awesome. So, yeah, that's it.
Thank you very much.
So, hello? Affordable housing, so.
yes.
We don't need it. Yes, everything.
They're all small,
Wait, you guys should come with me.
Go around.
Some technical difficulties. Or not. Never mind.
There's the camera.
Okay.
Hi everyone, we are Affordable Housing, and our mission is to provide more locations for the government to look into to further investigate in order to attract more mixed income groups to come to New York City. So can I see a show of hands again? Maybe I asked yesterday, but how many of you are thinking it's too expensive to live in New York City because the housing price is way high? Thank you. So in fact, as of 2011, more than a quarter of households in New York City spend more than 50% or more on their monthly income on rent. And in fact, New York City comes second on the list of most people fleeing. They're moving out of New York City. This situation scares a lot of talented groups like students, young professionals, nurses, teachers that are very essential for the society. So our solution for this problem is to rate different factors that are important to us, and based on different factors, we want to identify neighborhoods that has high potential for the government to look into and see how they could further investigate and better the neighborhood to provide affordable housing. And how do we come up with this? We first want to evaluate neighborhoods based on different parameters like vacancy, crime count, 311 complaints count, transportation, and then we process the high score interpolation model to generate a lift score. The higher the lift score, the higher the potential the neighborhood has. So we're looking for neighborhoods that has high vacancy, middle to low complaints count, and middle to low crime count. And then we suggest high potential neighborhood to government to look into. So now let's see some results. I just go straight to the results. So here we could see some potential sweet home. In fact, the greener the spot is, it means that it has higher potential and it has a higher score. And then the purple dot represent the vacancy. The bigger the dot is, the higher the vacancy, the numbers of available apartments there are. And when we see some overlap between the big purple dot and relatively high green spot, is kind of increase our awareness to suggest the government to look into some neighborhood that has high potential. For example, here is zip code, I think it's 1011 or 10011, and which is Long Island City. It's a pretty new neighborhood, and a lot of people are actually considering moving there. And it's currently having a lot of vacancy, which is suggesting to the government that we could further look into it and to attract more mixed income groups to come. And then another example here is Ridgewood in Queens, and it suggests similar results that we could further investigate and see what we could do. And we could also show you other data we have on the laptop. Well, when we're trying to figure out the data, but some further improvement or development we could explore is to add more data set. We could add demographic, we could add location, recreation, school system, and based on what demographic we are approaching for our different communities, we could weight it differently. So our model will spit out different scores. So that it's suggesting the government to further investigate different neighborhoods catering for different groups. And also we could, thank you. We're now open for questions.
So is ultimately the goal to suggest for public housing?
Public housing or a housing that government try to turn into attracting middle to lower income groups. That are now not really aware.
So is it for real estate developers, and is it like public-private, so that real estate developers are incentivized to make low-income housing available? I mean, I just know who's the customer.
The customer, I think we are mainly making suggestions to the government to look into and investigate neighborhoods. Either they have a high crime rate that the government wants to clean the neighborhood a little bit, or if they have a high complaint rate, then they want to maybe renovate the housing to provide a community that people are is underused to have a lot of available apartments.
Are there data sets available at a higher resolution in each zip code to reduce this, or would this be the application that is higher?
I think in the future we would want to make it more specific. Now it's for the ease of use, we are grouping it in zip code, but I think in the future we could maybe down the block and give each block a evaluation score.
Do you have the variables at that level?
Yes, because some of the data we are mapping geolocation to zip code, so we could actually show the geolocation. Thank you very much.
Amadeus.
Okay, I think Amadeus is okay.
That is correct. 1 second while we get set up.
Everyone just wait.
Yes. We'll kill the lights. We'll kill the lights in the front. Thank you.
Hello. Hi, my name is Fayam. This is Alap, Teja, and Dimitri in the booth, and I'd like to tell you about Amadeus. Amadeus is what would happen if Wikipedia and PayPal got married and had a musical baby. It's an encyclopedia of who made and who owns every piece of music in the world, a data set that hasn't been collected yet. We put digital contracts on top of that data to make music royalties flow from distributor to creator, simply, efficiently, and transparently. Now let me show you what we actually worked on in the last 24 hours. Now the trouble. Okay, so let's say you're an executive producer at a commercial agency whose job it is to find and license the perfect song for a commercial. Right now, surprisingly, this is a 6-week process where you're playing phone tag for weeks, just trying to find out who owns it. But let's see how you do it with us. Let's say you wanted to license the Empire State of Mind. You simply go to amadeus.nyc and type it into the search bar, which brings up a beautifully organized page of results, which you can search by song, artist, album, or year of release. When you find the one you want, you simply click on it to get an expanded page of credits and rights information. The 2 key pieces of data in the music industry are credits, or who made, and rights, or who owns a piece of music. If you're that executive producer for the commercial agency, what you're interested in is the sync right, which is the right to synchronize a piece of music to a piece of video. So when you click on the button here, this brings up 3 truly innovative options. You can either hit license now to buy the right to this music instantly through our online portal, as opposed to a 6-week process in the real world. Or you can hit name your price to suggest your own terms and price to the artists and owners of this music. Or if you want to go through a more traditional route, you can get the contact information for the person who owns this right. Consider another case where if you're not an executive producer, let's say you're a composer, and you just put together a piece of music, and you know you want to work with somebody who was on this track. Let's say you wanted the person who mixed or put together the various different instrumental tracks into one unified track for the Empire State of Mind. Right now, just like in the executive producer case, you're spending weeks trying to find out who that person is. But with our product, you simply go to the engineering tab under credits and find out that Ken Duro Ilfil and Chris Godby did the mixing for this song. In future versions of the product, you simply click on their names and get their contact information, other songs that they've worked on, and within minutes or hours are set up to collaborate with them. While all those are truly innovative in and of themselves, there's a little bit more that makes us truly exciting. You see, there's a cycle in the music industry that likes to repeat itself. New technology emerges, and this shifts revenue from old distribution sources to new distribution sources. The old distributors and the artists that rely on them cry foul that the industry is over because, for example, nobody buys CDs anymore. But then the turning point happens, where the new technology becomes so embedded in the industry's fabric that it enables entirely new ways to make and sell music, ushering in the new golden era. The magical thing is that right now, we're at another turning point in this cycle. Streams and downloads have crippled industry revenue, but they've also expanded its reach to a point beyond its wildest previous dreams. So much so that we're just one last step away from a new golden era. And what makes all 4 of us at Amadeus truly excited to be here with you today is that we just got started building that last step. Thank you.
Who on your team worked in the music industry before?
None of us.
What made you want to build it?
Well, 3 of us are lifelong musicians, and one of us is just a passionate musician, or a passionate music aficionado, I suppose. We actually organized as a team around the idea of building a distributed music label. Found out that that was an absolutely ridiculous, absurd, and unprofitable idea. Found out that this is actually a huge problem, that this data source does not exist in the world right now. It's very hard to collect. So we got around to starting to solve this problem.
So the problem is huge. How huge is the audience that's dealing with this?
Well, anybody in the music industry at some point has to get involved with the rights and credits to music. So there are various different players that get involved from different angles. We focus on the angle of somebody who's licensing because we're thinking that they will be our initial customer.
What are the areas you get in the data? I asked you a little bit about you go talk to the they want to come up with information prior.
So there have been various different attempts by government agencies, nonprofit boards, coalitions, etc., to get this data set in one place before. And our hypothesis is that the central problem is that all those attempts didn't have any financial incentive behind it. It was basically, here's me, this one big organization that wants to get created. Here's all you guys that have worked years to collect this information for your own business models. Why don't you give me your information and cede all your power? So what we're doing is create a financial system that perpetually incentivizes the centralization of this data. We say, hey, you give us this data, we're going to make use of it by licensing it, by opening it up by an API, by enabling new companies around this data, and then give you a cut of that money. So you're continuously incentivized to centralize it. So there are various middlemen in the agency who handle a bunch of different services, rights management, royalty collection, etc. And essential to their business model is understanding who owns and who made different pieces of music. So chunks of this database exist with various different middlemen around the world. Our core value is getting them to organize around one center of location.
Do you see a problem then with like guaranteeing correctness?
Guaranteeing what?
Like the correctness of that information. I say like you own the rights, and Drew says he owns the rights.
So that is certainly a problem that is going to be faced, but we're confident that we can face it if we. It is a surmountable problem, but it is a problem for sure.
So you said you plan on offering up this data set, this product, mostly for people in the music industry already. With the kind of growing creation of online video and the necessity of having music in online video and requiring licensing for that, do you plan on kind of spreading the word to that community, or do you want to stick with the music industry to get going?
Well, it's very uninteresting if you build something only for the incumbents, because then by definition, you're not really innovating in the space. Of course, when you get started, you have to have somebody pay you, so our initial customers will be incumbents. But the use case you just described is a fantastic way that this product will be able to enable new, fundamentally new products, right? If you make a user-generated video, if it were super simple to license music for that, and all you had to do was press a button, as opposed to spend 6 weeks finding out who just owns the damn song, then maybe people would actually get paid when their music is put on YouTube videos. And that would be really cool. Thank you.
Hi guys, my name is Kelsey. I'm excited to present Solar Out to you. So while they're getting uploaded, our team came together to solve a problem within sustainability using data science. So specifically, we wanted to look at solar energy, as solar is currently the most deployable, easily deployable, and less expensive renewable source in the States. So then we started thinking, well, if climate data is revealing that consumers should care about their consumption habits, how do you incentivize them to do so?
Yeah, too far.
No, since you extended it, we're going to carry it to you. Yeah.
It's showing some sunshine. Imagine the possibilities of fresh air. I'll just get
Yeah. Okay.
So we started looking at the cost and demand currently of PV sales. So obviously cost is radically reduced for the price per watt for photovoltaics, and the demand also has exploded, also provided because of incentives for different cities or suppliers of photovoltaics. So we discovered that the key barrier to entry right now in putting solar panels on your house is just not knowing how to do so. So we created a system that tells you guys are going to press the button for me. So we find the most effective location to install your solar cells. So our system is able to look at every roof and every spot on the roof and optimize for the long-term cost and energy savings of of solar panels. Ultimately, our system can be used by other city planners or homeowners as well. So our data only needs 2 inputs. So first is the map of your city, and then is the sunshine that your city has per location. Ultimately, our system could be scaled to any system, to any city. That's what's really exciting about our models. Unlike other models, it's easily scalable and transferable to other cities as well. So our system works like this. So first we have user inputs an address into our interface. We use a price data set of existing solar panels in the area. Then we look at the energy generated from the sun, the energy that's shining from different sides and longitudes. We then grab a map from Google using a zip code. And finally, we are using computer vision algorithms to classify the geometry of the roof. And we look at through the map. And then we put all those inputs together into a scoring engine that we created. And finally, each roof gets its own solar score at how good it would do with solar panel. So here's a snapshot of how our system works. So this is a map that we would grab from Google. So it zooms in, our system then parses and splits the map up into various sections, goes through each matrix, and looking at the roofs within each square. Okay, so first we're using an edge detector algorithm. So you can kind of see what the roofs are looking like here. We compare different models for doing so. So next we're also using another algorithm. So this one transfers color data to just 4 bits, and you can tell based on the aggregate color data which ones are roofs. And so finally, in terms of our score, we're looking at price efficiency of solar panels in different areas. So finally, we also gathered a database of various energy scores, of various sizes of buildings across Los Angeles, where we were looking specifically, and we compared our data versus what they're getting, and the results showed about a normal distribution comparing our results. And then finally, a system like ours could be compared citywide as well. So we're also looking at New York versus LA, price per unit, and what efficiency would be on different routes.
So did you take into account the time dynamic? Because the sun is very, very different. So this is an expectation over just one static time period, right?
It is absolutely long term. I'd love to look into that. Also, time of day pricing for PV cells, different states, and different incentives. For this weekend, we went with the basic model.
But for what? For data solar, what time period?
So we looked at the year, so the last year.
This is like the average of storage. Okay.
So it's average exposure over a year.
This is obviously expected to be a bunch of modules within the project. I can't imagine you finish all of it in this weekend. Like,
right.
What's really focused on the class?
Yeah, so I'll go back to the system diagram. Okay, maybe not. So first was the API that was grabbing images from Google. So we had that one work as well, where it would split the images up, and we had the longitude and latitude tag with each split image. We also had a good edge detector, so that was basic MATLAB. And then we also got, go ahead and explain the change in the colors in the.
Right, so we also figured out the potential markup was working as well. So we found a recent paper that tried to detect hatched fruits or solid fruits, as was also mentioned by Nadia. And we finally ended up having a k-means clustering algorithm, taking advantage of the fact that most urban landscapes have distinct 4 or 5 hues. So you just discretely map the colors into those 4 categories. We could get a lot of recognition for the filters. And finally, we also were very passionate about combining data sources, because one of the things that solar calculators exist, you can check them out, but a lot of them involve a lot of form filling, and then they give you answers. So one of the things we're trying to do is to collect data from Los Angeles City County Department. And so we also had data about building cycles, which they had collected, and building area, so that was website, and that's something also being talked. But as I said, it is a large project, and we don't have a fully idea system yet, but we're able to build the pieces together.
Yeah, great question. So this system would depend on so if the system wants to be marketed to consumers, we probably want to see like where on your group is the best place for solar panels. So if you're already able to get to that level, I think that's an amazing opportunity. In terms of impact of energy consumption within a city, I think utility company is the best way to go. And the way you could use that with the utility use model, for example. So if NextEra comes in, they'd be able to compare different locations. So this map, for example, would be color coded. So each building, each location would have a sticker with the rating of that spot. So a utility company could use that to make a decision based on where it might be a good place to place large-scale solar farms.
Just a quick addition, we might imagine doing it for free for homeowners to use, but if the utility companies or real estate owners, we might charge.
Thank you guys.
Hello, everyone. Thank you for coming out. So we are lyricists.
So here is our basic case study. Imagine Bob. Bob is a really successful singer, songwriter, artist. He's released a lot of hits, but he seems to have an imbalance between how much time he spends trying to find the right words and how much time he actually spends thinking about his creative outlets, actually producing fruitful lyrics.
So welcome to the solution, Lyricist. Lyricist offers data-driven solutions for songwriters, drawing from over 100,000 songs and producing recommendations that allow the songwriter to use their input and generate lyrics that are drawn from the most popular songs.
Yeah, so how do we put our data science technology into this awesome idea? So we came up with this data structure using directed weighted graph. It works like this. Suppose you have a simple node, then you have your string as your value, and you have an internal map mapping into the child nodes, the children nodes, and the corresponding weight value. Based on that, there's also an external map mapping every string from across all of the songs we imported into that node. So after import like 110,000 songs, we will end up some huge directed weighted graph like this one. So let's say a simple example here. Say I have word A followed by B, C, A, C, A. So I will generate a weighted graph like B follows A, C follows B, and A follows C with their corresponding weight on their different edges. After getting this weight graph, then we go ahead and perform the normalization. And we have also performed the shuffling algorithm. So we will import some randomness into our generated lyrics. Yeah, so speaking of the hackathon, what is my favorite factor of this hackathon? I would say it was the pipeline we created. So we created this huge pipeline so that there was no single piece of time wasted during our working process. So our data scraping guy, so scrape our data and pass the data to Yanfeng, and Yanfeng is a data parser guy. He passes the data and then parse that data to me, and I am a C++ professional modeling guy. And then I pass my model to Wayne for visualization, and then finally we have our D3 guy to put some final animation effect into our application. For our non-engineering team, they are also doing this awesome pipeline. We have John, who is an awesome creator, idea generator, and it loops his idea as an input to our designer, which is a genius artistic designer, Rose. So yeah, we have this like rolling stone infinite loop keep going. And welcome to.
As a whole, we form a minor graph group. So we'll give you a little example of what we can produce here. And we have a special guest, she'll just go on. So here's our
So this is the D3 working.
So you can see as he types in each word, it's generating recommended words. And I guess at the end of each line, we'll just throw it down. All right. Okay, so we'll wrap this really quick. All right.
Is
One, 2, 3.
Is this a demo or is this a training?
Sorry.
We have several lines, but.
Yeah.
Or a song informed by a powerful machine.
Yeah.
That's our general, yeah.
Wait, don't leave something. Any questions?
It's a history.
What are the words meaning?
Oh, there are the we generate the graph based on the population popularity of the words we suggest.
So you guys not actually taking the suggestions right now?
Yeah, so basically the larger words are the most optimal songs, and then based on the graph down below, these are all pulling from our database of 110,000 songs. And so the larger the word, the more recommended. But this is used more as a tool for assistance, right? So this is not just to generate a whole song. We created this rap just for fun, which the lines were originally generated, but it was more for fun. So.
But it's supposed to be recommending the next word in your song.
Yeah. So what it does is he can explain further, but it takes like.
Yeah. So basically, what you're saying, the word writing in the middle is the current word, and the word around the writing is the next recommended word. And it's all sorted by popularities. And since we merge some randomness into our application, so every time we generate songs, it's supposed to be a little bit different because of the shuffling algorithm. So that song is actually something we did generate when we are trying to come up with our songs.
So I do have like one model here that you generated, I think, with Kesha songs.
That's actually interesting. So this is just more of the basic prototype. Ideally, we would implement other features, other filters based on rhyme, number of syllables, number of repeated hooks. But we wanted to basically have something to produce with the hackathon. This is drawing from all different genres, and we'd also be able to like to sort by genre too. So if you're writing a pop song, we'd be able to select and we filter by that demographic of words.
And also the goal is not to automatically generate songs. So you are inputting a lot of the information. The goal is just, it's kind of to like take away the sticking points of writing a song, right? So you're writing a song and you may be struggling for that next word. Well, here you have a whole list of recommended words based on an algorithm that pulls 110,000 most popular songs and says, well, this is what they did, and this is how they got on the top of the chart. You don't have to do this. You can completely write your own song, but this is kind of taking away from that stick.
Let's do the rap.
The whole one?
Dance.
One, two, three. Is this a demo, or is this a dream, or a song? Imagine lyrics, create data, taking your song to the next level. Just beginning of the revolution. Lyricists, songwriters, woo! And we have the very first line that this ever created back in the testing stage, just a database of 10 words, was, I want to steal your freedom. So that's a pretty powerful line for just a randomized 10 song database. So pretty powerful. Yeah, thank you.
Open source communities are the largest and interactive communities. The open source community is one of the largest and interactive communities worldwide. GitHub is a platform that is used to help people create and collaborate across the world so they can also further their desired skills and learn new skills that they want. The thing about GitHub is that because it's so popular, there's millions and millions of projects that people are working on. It gets quite difficult for people to find projects. I know personally, as a user myself, when I created my own GitHub account years ago, I went on, tried to find a project, couldn't find one, and kind of gave up in frustration. Kind of learned those ones also.
So, GitRec's vision is to drive engagement in the open source community by pairing users of any experience level with projects appropriate to them, and more. Chris is going to show you how it works.
Okay. So how does our platform designed to answer all these issues? And as you can guess, it looks like a website. So basically, it takes your Git ID, and we'll see. It's kind of just a visualization of the background of what happens behind the scenes. So we go to the GitHub API, and for example, for that ID entered, these are some of the similar users, what projects they're working on, what they're coding in. These are some of the similar users that we recommend for you to look at. And then you can pick up a new project that's at the same level as you and possibly in the same language. So beyond connecting user to user, we thought a little bit further, on the cloud is great, but we thought, spatially, like in the real world, can we connect these people? Can we get them collaborating, in coffee shops and just get them talking and think about the amount of ideas that come out of that kind of collaboration. So this is just a set of, we take similar data, similar users, and just look at where they are across the globe. And then we take more broadly, basically a huge number of just anyone, regardless of what their interests are, like the locations of people on GitHub. So regardless of what your interests are, if you want to have a big meetup, you can imagine like 20, 30 people in a coffee shop just chatting about developing code. That's what we've done.
So what's next for GitHub? Outside the scope of this weekend, we can take the user IDs that we found that match similar skill levels and leveraging GitHub's API existing tools for filtering by programming language, by the complexity of the project itself. And also look for those projects that are out there that are open source, not private, that have open issues, that are appropriate to the skill levels of the people who are looking for something to do. the way it made sense to me when I presented it is I like to play chess with people who are a little bit better than me, so I can grow. But I also like to help other people out as well. When the mismatch is too great, as is what's common in the recommendations that you'll find just by using GitHub's native tools, it creates this disengagement. And for new users like us, we just don't even involve ourselves in the community at all. So at this point, I'd like to turn it over to the judges for some questions.
Back up. So your tagline says, predict some of the best projects. Predict those fine.
It's to recommend. I think that might be the best way to articulate it.
How do you determine coder skill level?
Well, the metrics that are available to us don't allow us to penetrate deeply into that. But we've been able to crunch the numbers a little bit using the complexity of the projects that they've been on before. How many active participants? What are the sizes or the impact of their commits? Although it's a little subjective, but also to see what kind of languages that they're working in, how big are the file sizes, stripping out for images, et cetera, just looking at the code base as well. So we do have some metrics that begin to approximate what the users are involvement, and also look at the users that they participate with, and then go and look at the projects that those people look at and get the sense of kind of how do you fit into the ecosystem.
When you put in that ID and you go and you see this, those are the users that are like you, is that based on, what is that based on?
So I'll turn it over to Sasha to talk a little bit about some of the algorithms that we tried and where things are at today.
Yeah, so far we just started doing just use of easy collaborative filtering. So we couldn't get all the data we wanted by the time we had. So we only used the user IDs and project IDs. So we just looked at the users who worked on a similar project and then come up with a similarity metric. And then so we weighted by the metric, and then we can do like majority vote by the people who have similar like high similarity metric to those people. As the first step. But then we can also integrate like between them. So we can cluster the projects instead, and then instead of doing it user by user, we can do it project by project. And it's a big thing we can do like a hybrid model. That's like a very big picture.
Business, which part of it would you charge for?
I guess I can do that. So what we learned quickly, whether or not it's a good thing, we learned how massive the API, GitHub's API is. So I think we can generate a lot of valuable data. Just one of the things we discussed further out, like maybe each month looking at what like users actually contribute to things we suggest. And since GitHub is open source, I'm not sure if there's money that they would have with us, but I don't know, maybe there's a cell somewhere for the data we're generating, looking at, based on time, what percentage of code people are working on. I'm not sure. That's a good question.
So I'm Andrew, this is Chris, Crystal, and Sasha, and I'd also like to give a shout out to Vera, who's not only the youngest member on the team, but also the driving force and mastermind behind this project.
I also want to thank my team. I am so lucky that I get 2 PhD and 1 master, and it's one awesome lady there helping me building the things I want to build. So thanks everyone.
Okay, so we have 2 teams left. Any, do you guys know? Yeah, clarify is
Hey, okay, so first of all, I'm sorry. I'm just going crazy. I don't know if that's just me or. So the main sort of inspiration, maybe the reason why we're out here right now, is kind of this big data explosion, basically. Warsaw, all that kind of stuff.
And there's this desire to have both really smart algorithms introduced into our lives and elegant interactions with this intelligence, so that we can all find a little bit more of our own little utopia. So in this slide, the project was inspired by frontiers in 3 separate disciplines, which are separate, but we will see potentially very connected. Statistics, and then visualization, which is, there's definitely connections we see here. But something that we're introducing that is both risky and roller coaster ride is a lot of stuff in human-computer interaction. So I'll go through each of these components, and we'll have different members of the team explain these components. So what you're looking at right here is Wikipedia articles that we collected, and with the words inside all of the articles, we ran term frequency and versus document frequency on top of that to emphasize what are the most important words in each article and get rid of all the garbage. And then we have this high-dimensional space that doesn't look like this, and maybe this is not the most elegant visualization itself, but this is a start. There we go. And it's really high-dimensional, but it's hard to get much information out of that. This is just a bunch of vectors, and in fact, there was a 60,000 dimensional vector, and we collected 1,000 articles. That actually was ambitious, given the optimization we ran on top of it. So from Jeffrey Hinton in 2008, we had the term T distributed stochastic neighbor estimation. And what that did was take that high dimensional space and reduce it down to any number of dimensions you want, based on like a principal components analysis type of approach. But in particular, we took it and put it into 3 dimensions. So the fun big step here was to take these Wikipedia articles and you can kind of navigate through this world. So you're seeing that countries are kind of close to each other. Tupac Shakur was close to sex. Gets a lot of that. We have a lot of interesting stuff going on that was just naturally kind of established from the words inside the articles. And this is a really elegant way of sort of interacting with that much information. It's very intuitive. You quickly get a lot of information. And this is where the fun kind of happens, is because suddenly you can introduce a lot of information on top of this data structure and on top of this interaction medium. So it's all prescriptive. So basically, we're able to provide this immersive experience. And what we were looking to introduce to you today, in particular, was, hang on, I'm gonna focus on for a second. Yeah, I'm sorry. Great. So what we're looking to do with this Oculus experience, this is the Oculus Rift, this is why it's kind of got double vision, is have it so that we're going to put Twitter streaming onto each of these topics. And we actually have all of these components built. We had issues with how much hardware processing, distributed processing, integrating all of that over networks. But what we do have is basically sentiment analysis in a separate streaming component where you could potentially have the colors of these balls represent how people are feeling about this. And you can, now I'm going to introduce the, oh, we're looking at questions. Okay, well, I just wanted to say one more quick thing, and I'll bet my Anton. Okay, so there's just one quick thing about the Microsoft Connect. So this is another third layer, the human-computer interaction layer, and we're now demonstrating that we wanted to provide a way to interact with the Oculus world, because you have this immersion happening, but there's this problem of, okay, it's beautiful to see, but how do we actually, grab things and travel in it? So we found some gesture recognition libraries for hand recognition. And the simple idea that we have is basically, you can travel from your topic to topic. So instead of just having like 100 topics or 1,000 topics, imagine all of Wikipedia, and imagine all of Twitter, and imagine all of whatever you want on the internet visualized for you, simply, with all of your modules that you're interested in. and then just having a seamless grab and pull as you dance through your worlds elegantly. So hope you enjoy that. So this is our project. Thank you. We're welcoming any questions, and we also have some very talented team members who were incredibly important to the vision and the execution.
So, who's the key buyer or user of this application?
You, consumers. So I think basically this might be a look at what the future of the interaction with the World Wide Web and the internet might be. It kind of reminds me of the internet in the 1990s, the early 1990s, where it's clunky and it's graphically messed up, and we also have some other benefits.
So here's an anecdotal experience that we just had today is somebody's daughter was walking around and she tried on our technology and she's like, wow, this is actually really fun. So we think data can be fun, it can be engaging, and it's a way to add value. So no longer do you have to just stick to your plain and dry PowerPoint and Excel, but you can add so many different attributes and features and make them intuitive as you navigate through the space that you can convey so much more information in a much more intuitive manner. And it's the stuff of the future, really it is.
Clearly a big project, clearly a lot of parts of the Untitled Tech. What's the biggest breakthrough you guys made?
This is something that I think everyone can benefit from, which is not just the obvious glam, but the notion of taking really high dimensional spaces and bringing it into 3D. We were shocked by how easy to use and like quick and powerful the TSNE algorithm is by Jeffrey Hinton. That was amazing. And we did a lot of pre-processing to get the data fit into it, but it's what you would expect. It's very direct. It's just matrix normalization, basically. So I would say a lot of data scientists could benefit from taking and putting their data in a 3D space. It's cool, and people get a lot out of it real quick.
If this was going to be a product that you would sell, would you market it as a learning product or as a game?
It's a big question. I would definitely market it as a learning product, not a game. And I think that represents sort of an under-recognized aspect of the virtual reality space and the graphic space is recognizing that it has so much potential for industrial purposes, for consumer applications, and these types of things.
So I know you had some like spatial relations going on as far as like association.
Yeah.
And you were talking about colors and some stuff that Mark said to me. I guess the first would suggest to me that this is an exploration tool, and the second would suggest to me that this is like a monitoring tool almost.
Exactly. I think I see it as both a dashboard potentially, and also a way to just kind of dive into some really awesome knowledge space, maybe publications in the scientific domain you're interested in, or something like that. Thank you. Clarity.
Thank you.
So this is the last team personify.
Hey guys, I'm Gen.
I'm Judy.
I'm Thomas. And today we're designing a search engine for people called Personify. So the problem that we're trying to solve, and Personify is a search engine that finds people based on skills and experience and attributes. And the problem that we're trying to address is that it's really hard to find someone. It's hard to find when a target is on a platform because the search field is often limited. For example, this is LinkedIn. And what if the person doesn't even have a profile, or the profile he has is outdated, which is actually often the case. So we studied a data set of Cornell and MIT alumni for people who have been in the work for the past 10 years. More than half of those people don't actually have a LinkedIn profile. So what do you do for those people? Right. So is there a way to search for people without relying too much on the action from the user themselves or the structure of the platform? And we think there is. We want to build a search engine for people by using unstructured written text. And the way we're going to do that, and for this hackathon, we're using Crunchbase as a trial basis.
So very briefly, we got the raw data from Crunchbase of about 200,000 people. And to each of these people, we attached tags, which we used a keyword extraction algorithm from Alchemy's API. And with this, we not only give a list of people that you're looking for, but we also return interactive graph that we'll come back to later. And for the purpose of our demonstration, we reduced our pool size to about 4 people. So you can search for whatever term you're looking for, say Microsoft, and then we'll give you the people.
Yeah, so not only based on the company name, but we can also search based on the description of their job or what they put inside the description. So much more than what LinkedIn or other similar products can offer us today. So here we have these names for associated with product management or associated with MBA. Now this is great. It's a list of names, but can we do a little bit more to increase relevancy and figure out who are the most relevant people from that? So here, to the platform, I give it my own data. Based on my LinkedIn profile, it understands that I'm an MBA student. I went to MIT for undergrad. And here is highlighting me the product managers who have, or associates with MIT, are blue circle, and for the light blue circle, those are product management who have MBA degree. So that's all great. So that's the back end of a search, and that is going to power how we're going to allow people to find other people on the web. But what would the UI element look like? Well, we think it could be pretty simple for how Guido would do this today. So for Personify, we ask the user to first register or log in to get a little bit more information on that person, and then keep on going. Now from the search engine, just type in whatever you want to find, and immediately we return you people as search result rather than websites. Now this can also be integrated with a prompt, so as prompt extension, and we can partially augment search results from Google with people search results from Personify. And that's our concept. Thank you very much. Any questions?
You're going after people who are looking for, like recruiters who are looking for candidates who might not be looking.
So not only recruiters per se, but we think that people are much more relevant as search results for some cases. Recruiting is definitely one of them, but what if you need help with some sort of expertise, right? Be it coding, or maybe you're doing a M&A deal in some industry that you've never dealt with and you want to speak to your friend from that field. Well, what if that friend is not on LinkedIn, or you just don't know that friend even existed in the first place? So we want to basically surface information about people you already know, and based on relevancy, we will surface the people most relevant to you about that situation. So this recruiting is one use case, but I think it's a much wider application of this.
They use it for online dating.
Yes.
It's a big question, so appropriate answers might be out of the know, but how do you handle privacy and like data control over like my image on the internet? When I'm being like we're pulling data from something that I don't have like direct curation.
Right. So we do not show you anything that you couldn't find yourself. So again, this does not. So if I'm searching for you, I do not, I guess, need your permission to read articles about you on the web. So this basically streamline all that process and put that into one place so that you can find a lot of information about that person without doing all that search yourself.
I think I quite understand how you solve the problem of someone who doesn't have a big profile.
Right. So we will look at what other people have written about them. So all the Crunchbase profiles they're not written by people themselves. It's written by TechCrunch journalists or other people in the industry. So there's this wealth of data in the past few years that are generated by other people not themselves.
But it's not solving the problem of someone. It's hard to find it. It's solving the problem of someone who doesn't self-promote.
Right. And with the proliferation of all these platforms, it's really hard to keep up to date on every single platform all the time. If you have friends from multiple fields, it's often the case that you're isolated within your own platform. Right, so right now it's only from Crunchbase, but this is easily adaptable for any body of text. So what we're doing is taking a body of text and running that through natural language processing. We use Alchemy API for that, but there are other libraries that we can use. And it doesn't have to be from the Crunchbase stream, right? It could be from Wikipedia, from New York Times, from a magazine quality.
Thank you.
So thanks, guys. That was the last team. Everyone, please thank the judges for listening to
As soon as they pick the winners, we'll come out and make some announcements. Okay? Just feel free to eat some food. There's a fridge full of Red Bull. Okay, shortly. Oh, and feel free to cut into the cake.
Also, as a quick note, you might want to try and get contact info of people you work with just to stay in touch. You never know when it might come in handy, you need connections. So yeah, make some friends, guys.
Yeah, Jake had this great idea, create a Facebook event around this, and then just send everybody the link so you can join the event, and then without disclosing everybody's personal emails, you'll be able to connect with each other. Okay, so expect that maybe tomorrow afternoon.